Hello my dear students, good afternoon. Now let's see structure of NaCl unit cell. See why we have to learn NaCl like structure is for a particular AB compound and A atoms are present at corners, B atoms are present at somewhere and what is the formula of AB like that they'll ask you. So to understand like that NaCl like structure somebody is having means how many effective number of atoms are existing. These all things we must know clearly. Okay, so now let's see structure of NaCl unit cell, because in total unit cell how many Na plus ions are present and how many Cl minus ions are present. Let's see now. In previous for atoms and for ions, commonly I was given what is face centered cubic, what is FCC, BCC as well as HCP and all like that. But here I will give you what is NaCl crystal lattice. So somewhat it's a big and complicated in the sense we must know clearly. So this is, here you have like this. So what I am doing understanding, so I am drawing this cube 1, 2, 3, 4 like this here. Okay, now just combine these all diagonal edges. Diagonal edges you combine like this. Like this you combine, so that you can understand very easily. Okay, so better to have one more time like this. That means you have to change this little bit. Okay, and now wait a minute, 1 minute. Okay, like this. Now what I did, just observe everyone. So I was drawn first cube and these 4 diagonal edges I was combined. So next what to do means, just listen carefully. These diagonally where you have here one diagonal and here one diagonal you have. So in middle exactly those diagonal edges you have to draw here like this and like this. So combine these two like this. So what I am doing understanding? So you have to draw like this. You have to draw these diagonal edges. Those diagonal edges you have to combine and middle line you have to draw like that. Understanding? So again same manner, the same diagonal, this top to bottom you draw. Now left to right you have to draw. Just listen carefully so that you can understand very easily. Okay? Like this. You are having like this. Okay? So in middle you have like this, and in middle also you have to draw one more line. Okay? So hope you understood. Is it complicated? So I was drawn this line and this line. Okay? And I was combined here to here and here to here. And in middle you have to draw one more line like this. Or so this is what NaCl unit cell. So here suppose Na plus ions are like this, red color dots. These are what? Na plus ions. And Cl minus ions I am representing with this black color. So these are Cl minus ions. So these Na plus ions and Cl minus, because NaCl is having ionic bond. So Na plus and Cl minus are adjacent. Okay. Suppose if I start Na plus here, I will have Cl minus here. Pakka. If I start Cl minus here, here Na plus. That's not a problem. So I'll start with Na plus. Okay. Na plus ions are present like this. NaCl present at corner. So next here you are having Cl minus like this. Who is this? Cl minus. So again Na plus here. Got it? So Na plus This is what? This is Na plus and this is Cl minus. Now Na plus here you have, so here again you will have 3 ions here, cation and anion. Here you have Na plus, so here you are having Cl minus. So I hope you are following everyone. So this is Na plus, so this is Cl minus. So again here you have Na plus. So here you have Cl minus again. Got it? So here Na plus and Cl minus ions are alternatively present. So Na plus, Cl minus, Na plus, Na plus, Cl minus, Cl minus, Na plus, Na plus, Cl minus, like that. So they exist alternatively. And again here, this is Cl minus, so here you will have Na plus. So that's why I am drawing like this. So here Cl minus, Na plus. Again here you will have Na plus, right? Red color Na plus. And this one here you have Cl minus. So you observe total in one layer, 3 layers total. So 1 and here in middle is second layer and here you have a third layer. Okay. So total in one layer there are 9. Total how many? 9 ions you will have. Here also you will have total 9. Okay, and I forgot to draw one more line in middle like this. Sorry. It's drawing only somewhat not difficult, but it's somewhat this. Okay, so here you have in middle like this. Okay, and here what you have again, this is Na plus, so here you have Cl minus. So this is again Cl minus. So in middle what you have? Na plus you have like this. Okay, and here you have Mr. Cl minus, so Na plus here. So here you have Na plus again. So alternatively I told now. So here Na plus is there, means in middle who is there? Cl minus is there. So I am telling you that note this, it's not mandatory to start with Na plus. Okay. If Na plus I am starting with corner, then you will have Cl minus at edges. You observed or not? Okay. So here if I start this Cl minus here edges and the same will be at body center. You have to identify those positions. And here you have 3. What are those? Here Na plus. So here you are having Cl minus. So here you are having Cl minus. That means here in middle what you have? This is Cl minus. And this is Cl minus, this is Cl minus. So in middle what you have? Na plus you have like this. So that's why to draw it's very simple for you. Okay. So now what you have? Like this. And here you have Na plus and Cl minus. Here Cl minus. So here you have Na plus. And this is Na plus. So otherwise you can have here. This is Na plus. So here you have Cl minus here. Okay? So this is Cl minus, Na plus. Na plus, Cl minus. Na plus, Cl minus. Alternatively you are getting or not? So here again what you have here? Na plus. Na plus. Because this is Cl minus. This is Na plus. I was drawn here. I was written here. This black color is Cl minus. So here what you have again, this is Na plus. So Na plus won't come here. So Na plus will be here. So here you have Cl minus. Here you have Cl minus. Here you have Cl minus like this. So here you have Na plus. And here again you will have Na plus. And here in middle you have Cl minus like this. So this is total NaCl sodium chloride unit cell. Okay. So why I drawn this NaCl unit cell? To understand their positions. Na plus ions were present and Cl minus ions were present. You can have clarity here. Okay. See, if you observe what here what you have Na plus, right? This Na plus ions where you have, if you observe everywhere, Na plus ions are present at all corners. 1, 2, 3, 4 and 5, 6, 7, 8. Correct? So where Na plus ions are present, Na plus ions are present at total unit cell I am considering. Okay, NaCl unit cell. Na plus ions are present at all 8 corners. All 8 corners plus 6 phase centers. 6 phase centers. In previous for atoms we had just only phase centered cubic like that. So here entire NaCl crystal system exists like this. Why don't ask me? It exists like that. Getting? So where Na plus ions are present means Na plus ions are present at all 8 corners and 6 phase centers. Na plus ions. You can check here. See, this is one phase center, Na plus. Understanding? Na plus means red color. 1, it is second phase, third phase, fourth, fifth and sixth phase. So 6 phase centers have 6 Na plus ions. So Na plus ions are present at all 8 corners and 6 phase centers. 8 corners and 6 phase centers. Who is present? Na plus ions. Understanding? Same way, in a similar way, where you have Cl minus ions. So Cl minus ions are present. Cl minus ions are present at all edge centers. All edge centers plus where you have one body center. All edge centers means how many? 12 edge centers. How many? 12 edge centers you have. Got it? And one body center. That means how many Na plus ions are there? Therefore, Na plus ions are is equal to total 8 plus 6. 8 plus 6 means 14 Na plus ions are there. In a similar way, how many Cl minus ions are there? Cl minus ions are 12 plus 1, 13. This number can be reversed. Means 13 Na plus ions and 14 Cl minus ions. Like that also. They will mention, you have no need to worry. How we can come to know, sir, whether 14 or 13 Na plus means? They will mention in question. Na plus present at corners. Okay. Who are present at corners, they are also present at phase centers. This is very important note for you. Okay. So what I am telling, understanding? So Na plus ion is present at all corners here. These 4 corners and these 2 corners and these 2 corners. 8 corners and phases. Phase centers how many? 1, 2, 3 and 4. 5 and 6. 1, 2, 3, 4, 5 and 6. 6 phase centers you have like that. Getting what I am saying? So this is NaCl crystal lattice, and now in NaCl, what is Z? What is Z means? Effective number of atoms or ions here, because Na plus ions. Okay, suppose how many Na plus ions are there? Means you have 8 into 1 by 8 plus 6 into 1 by 2. That means effective number of Na plus ions how many? Na plus ions how many? Means you are having 8 into 1 by 8 plus 6 into 1 by 2. That means 1 plus 3. That means 4. So effective number of atoms in NaCl is 4. That's why we can consider it as FCC, phase center cubic, or CCP, cubic close packing. So effective number of Na plus ions, how many you have means 4. Getting what I'm saying? And similar way, how many Cl minus ions? Effective number of Cl minus ions, Z is how much? This is our question. So where you have these all Cl minus ions, you can see edge. These are edges. This is edge center. This is edge center. This is edge center. So like that 12 edge centers you have. At the same time, those also present at, that means Cl minus also present at body center. So Cl minus ions present at all edges. 1, 2, 3, 4. These are 4 edges. 5, 6, 7, 8. Okay, 9, 10, 11, 12. Like the 12 edges you have, right? Getting what I'm saying? 1 in this way, otherwise 4. In this way you have 4. And 4 over, so you have 5 and 6. So total, in that way, total 12 you will have edge centers. You can check here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is, this one. 8, 9, 10, 11, 12 edge centers. And also Cl minus present at body center. So Cl minus ions are present at all edge centers in my diagram. If you start Cl minus here, then instead of Na plus, we have like Cl minus here. Getting what I am saying? So these are very important. So Cl minus ions were present, and how many effective number of atoms means? So here 12 into 1 by 4. I told you na, edge center atom shared by 4 units cells. So 12 into 1 by 4 plus 1. So here it is 3 plus 1. So effective number of atoms, how many for Cl minus ions? That is also 4. So in NaCl unit cell, the number of Na plus ions are 4 and the number of Cl minus ions also 4 only you are getting. That's why you can change their positions I am telling. Getting what I am saying? So this is about structure of NaCl unit cell. Getting? So in NaCl, what is the coordination number? Coordination number is 6. Simple. One example I will tell you. Around this Cl minus, how many Na plus are there? Red color spheres, how many are there? Around this Cl minus ions you can check. 1, 2, 3, 4, 5, 6. That means coordination number is 6 for NaCl or else NaCl like structures. KCl also is similar to NaCl. Getting what I am saying? So this coordination number for NaCl is how much? Means 6. How you are saying means same way here. You can count here. What is coordination number definition? The number of oppositely charged ions surrounded to one ion is called coordination number. So what is coordination number? Means 6 for NaCl. You can count. Anywhere you can count. So then here if you count around Na plus, how many are there? Means Cl minus 1, 2, 3, 4. That means remaining 2 ways, 1 here. So total 5. See for this Na plus, this is Na plus now. How many Cl minus ions are there? Means 1, 2, 3, 4 and 5 you have. Then where is 6th one? This is one unit cell. Another unit cell will be adjacent. So somewhere here you have Cl minus, which is belongs to other unit cell. Means which is beside to this particular, this which is adjacent to this particular unit cell. That particular unit cell have Cl minus. Okay, this Cl minus will be just like this. So for this, how many you have? How many you have Cl minus ions for this Na plus? Means 1, 2, 3, 4, 5 and 6. But this Cl minus is not belongs to this unit cell. This Cl minus belongs to adjacent unit cell. In that way, what is the coordination number for particular NaCl unit cell? Means it is 6. Hope you understood. You have to draw this very clearly. Okay. So what is coordination number? Everything, and put a pass otherwise, and have a screenshot and write down all these things. What is the coordination number? I said 6. And who are Na plus? Red color. Who is Cl minus? That one. Who is that? Black color sphere. Okay. How to draw, you remember? Otherwise, I will draw it again if you want. Very simple. I will tell you how to draw. Okay. So first time only you have. Otherwise, just listen, recap this video so that how to draw you can understand. Okay. So first you have to draw cube and then you have to write down. First you have to draw that cube. Okay. So very simple. First you have to draw like this. So like this. Like this you have to draw. Okay. so cube over. Next, these 4, just draw along with me. These 4 edges, these 4 diagonal edges, you have to connect. Do that one. How? 1, 2, 3, 4. Like this you have to connect. Connected 4. Getting what I am saying? So these 4 you connected. Now what to do? Just the same in diagonal manner you have to draw in middle like this. Connect these 2 now. Or connect in middle also. Over. What I did understood? In middle I was drawn one more diagonal edges. So here one more and here one more in middle. The same way now in middle like this, left to right. Top to bottom in middle we drawn, and now left to right we have to draw like this. Combine these. Okay, in middle also you combine and keep like this. Over. So start with Na plus and write down Cl minus here. So here Na plus, suppose I was changed. So this is Na plus, now this is Cl minus. It's not a problem. Like that. Now you can fill it. So this is about NaCl like structure. NaCl has, if Na plus ions are present at corners, the same ions also present at where? That is an important question. They'll ask you, Na plus ions are present at corners, the same Na plus ions are present at where? In NaCl crystal lattice, means also present at corners. If I start, I repeat, if I start Cl minus at corners, so the same Cl minus ions are present at face centers. If I start Na plus ions are at edge centers, then those 12 edges of Na plus ions, along with that one Na plus ion is present at exactly body center. So but whatever, if I started Na plus ions at corners, they are also present at face centers. So if I start Na plus ions at corners, the total Na plus ions per unit cell will be 8 plus 6, 14. But effective number of atoms, 4. Don't get confused, because those atoms are shared with other unit cells. Those all atoms are not belongs to one particular unit cell. That I was mentioned very clearly in previous. Getting what I am saying? Then here I written 14 Na plus ions are present. Is all 14 elements, 14 ions are belongs to one unit cell? No, they are shared with other unit cells. Corner atom shared by 8 unit cells. Face center atom shared by 2 unit cells. That's why I written 6 into 1 by 2 in previous. So this is all very important for us. Okay, next structure of Mr. Cesium chloride. Structure of what, sir? CSCl. Very simple. It's having BCC, body centered cubic. NaCl, FCC. Effective number of atoms also you have 4 in previous NaCl. For BCC, very simple, body centered cubic. So body centered cubic means you have like this. It's very simple. Don't worry. It's not that much complicating diagram. So here you have like this, and very simple. Here you have suppose Cl minus ions like this, 1, 2, 3, 4 and 5 and 6, 7 and 8. So Cl minus ions are present at corners, only at corners, no other choice. This is about CSCl, cesium chloride, body center. Cl minus ions are present at where? All corners. Body center. This is a red color. Cl minus ions I am representing with red color. So here. And yeah, that cesium chloride I am representing with this black color. Okay. So what is this? Cesium plus. That is Cl minus. So in CSCl, how present? 8 corners. 8 corners occupied by whom? Cl minus ions. Pakka. Don't consider 8 Cs minus ions and 1 Cl minus. No. Okay. Here 8 corners occupied by Cl minus ions and 1 body center. Body center occupied by Cs plus. So Cs plus must be in middle like this. So Cs plus you have. These all are connected with the same distance like this. Same, it appears like this, but this body center Cs plus is in equal distance to every corner. Getting what I am saying? So this is about cesium chloride, and here how many effective number of Cl minus ions. Cl minus ions, how many means 8 into 1 by 8 is equal to 1. And same effective number of Cs plus ion is how much? Means how many? Means this is also Z. It must be same because they are existing in 1:1 ratio. NaCl 1:1. So effective number of atoms must come in same ratio. Getting what I am saying? It is not calcium chloride crystal. Then ratio will be different. I will tell you about all those crystal lattice again. Means afterwards. Okay, don't worry about CSCl, about ZNS. They are different. These are different. Okay, so here also just one we have to consider, because body center atom means only one. Body center atom will not be shared with any other unit cells. So Cs plus ions is equal to 1 and effective number of Cl minus ions is equal to 1. That's it. Okay. Let's have one numerical based on this. Okay. So same kind. So you have to take a screenshot. Cesium chloride has what structure? Body centered cubic. Effective number of atoms how many? Means total 2. Because body center na. Effective number of atoms total how many? 2. Get it? So these are very, very important for us. Okay. So effective number of atoms for simple cubic means you have to consider what? Effective number of atoms in cesium chloride means you have one Cl minus and one Cs plus, one Cl minus. So total 2. So like BCC, in BCC effective number of atoms how many? Means what you will say? 2. Like that only you have to consider. Okay. Now let's see one numerical based on this particular. Okay. Same concept. So here I will write that one numerical here. If crystal lattice has NaCl like structure, and A ions occupied at all corners, and B ions occupied at edge centers. At where, sir? Edge centers. At where? B ions occupied at edge centers. Then and one more thing here I have to say, and if from one of the axis face center atoms missed, then formula of AB. This is the question. Read once again before I can write, but you also will read with me. You also can write with me. If crystal lattice has NaCl like structure, A ions occupy at all corners and B ions occupy at edge centers, from one of the axes, this is very important data for us. From one of the axis face center atoms missed, then formula of AB is, this is the question. What to do now? What to do? Very simple. Actually, A plus ions present at where? A plus ions are present at 8 corners. Correct? Because they always said all corners. So A ions present at 8 corners. Just previously I was given. If NaCl like structure means who are present at corners, they also present at face centers. I was given or not in previous here I have written. Na plus ions are present at 8 corners and 6 face centers I was given. Otherwise you just recap the video. Just go back. You can come to know. So A plus ions present at corners means they also present at 6 face centers, right? But what they said, from one of the axis, atoms removed. Which atoms removed? From one of the axis, face center atoms removed. Face center atoms removed. Now what to do then? Very simple. There are total 3 axes, total 6 face centers. Means 3 axes having 6 face center atoms means one axis face center atoms removed means 2 atoms removed. I repeat, there are 6 face center atoms. Here ions. 6 face center ions are present in 3 axes. Means in each axis there are 2 ions. So 2 ions we have to remove. Therefore, what is the thing? Therefore, 2 A plus ions at 2 faces have to remove. This is the important note for us. Getting what I am saying? Because AB has NaCl like structure. A plus ions are present at all corners. That means A plus ions also present at face centers, but they was not given in numerical. A plus ions are present at face centers, they was not given, because we must know, because they given NaCl like structure. So A plus ions are present at corners means they also present at face centers, because just in previous I was given that NaCl crystal lattice unit cell structure. So here how many you have to consider means only 4 you have to consider. Getting? Now what is Z? To say formula Z you have to calculate. So 8 into 1 by 8 plus just 4 into 1 by 2. Instead of 6, why I taken 4, understood? This is very important for us. If you have any doubts, personally you can ask me. 8 corners, actually 6 face centers I have to consider. But if there was not given this, from one of the axis face center atoms removed, from one of the axis face center atoms missed. So one axis consists of 2 face center atoms, because 3 axes consist of 6 face centers. Because total 6 faces now in 3 axes. So here how many Z for whom? Effective number of A plus Z plus. Oh, I'll write like this. Z plus for A. Oh shit. Z for effective number of atoms for A plus. How many means? It is 8 into 1 by 8, 1. 4 into 1 by 2, 2. So it's 3. So simply I know this is A3. Now come to B plus. So B minus. B minus ions are present at where? All edges, means 12 edges plus 1 body center. So there was not given no sir 1 body center. Then why you are writing? Just in previous I was given Cl minus ions I was represented at edge centers. The ion which is present at edge center, that is also present in body center. So it's very simple for me. Here no ion is missing. So what is Z for Mr. B minus? It is 12 into 1 by 4, because edge center atom shared by 4 unit cells. So 12 into 1 by 4 plus 1. So it is just 4. That means B4. Okay. Therefore the formula is A3B4. What is the formula? A3B4. This is a previous IIT question it is. It's very important. You must notice that this AB has NaCl crystal lattice. A ions occupy all corners. Who are present at corners, they are also present at face centers. But instead of 6 face centers, I am considering only 2 face centers. Because what? Because this is having two atoms missed there at corners. Okay, so in that way I have A plus ions and B minus ions. B minus ions are present at edge centers. But why I was considered body center also? Who are present at edge center, that is also present in body center. So therefore I have this 12 into 1 by 4 plus 1. So 12 into 1 by 4 means 3, 3 plus 1, 4, B4. So A3 and B4, because A plus ions are 3 and B minus ions are 4. So A3, B4 is the formula. Okay, got it? Thank you.